All right. Today, I think we're going over the super keyword. If you want to click on super keyword, that would be great. I'd appreciate it. Takes you to super keyword. So I'm going to write topic super. Get out of here. Super keyword. And if you want to know, I believe it's like 9.4-ish maybe on CS Awesome. Okay. We are going to talk about the super keyword. I noticed that we didn't add anything to our notes about inheriting accessors and mutators, so I just wanted to add that really quick. I found a pretty decent slide to just talk about that momentarily. It just says, recall that in inheritance, subclasses automatically inherit the instance variables from the superclass. Since these variables have private visibility, how does the subclass access them? Well, the answer is by using the appropriate inherited get or setter method. And if you guys didn't know that already, I guarantee that doing the processing activity definitely got you used to using accessors and mutators or getters and setters from the parent class. We're not going to do these activities, but I just wanted to write that down because we didn't have it written anywhere in our notes, so I just wanted to make sure we have it written down somewhere. Basically, to access the values of the parent class's instance variables, call the inherited getter methods or accessors if you want to call them that. And then also basically the same sentence, but to change the values of the parent class's instance variables called the mutators or setters. Call the inherited setters or mutators, however you want to call them. Something like that there. Okay. So I just wanted to make sure we had that in our notes. I know you definitely learned it last night or yesterday when we were doing the stuff with the ball class. Because how else are you going to look at these private instance variables from another class? Well, just like before, you have to use the accessors and mutators. However, in this case, they're inherited. So we can use them just like they're our own. Notice you didn't have to call them on an object. You just said get x or get x velocity or set color or something like that. And you did that just because they're inherited. So I wanted to make sure we had that somewhere in our notes. Now that we have it in our notes, we can move on to this link 9.4 super keyword. Okay, so we learned one use of super. What do we know that super does right now? Calls the parent class's constructor. Very good. Super can be used for other things as well, and that's what we're going to learn today. It says sometimes you want the subclass to do more than what a superclass's method is doing. You want to still execute the superclass method, but you also want to override the method to do something else. This happened last night with the ball class. If you overrode display, for example, after you did everything that you wanted to add in display, you still had to change the fill color, and then you still had to draw the ellipse. But maybe you wanted to do some other stuff on top of that. Since you have overridden the parent method, how can you still call it? You can use super.method to force the parent's method to be called. We've used super before to call the superclass's constructor. There are two uses of the keyword super, and you better believe we're going to write this down almost verbatim. Number one, if you just say super or super with some parameters, it's just calling the superclass's constructor. Super is just like a fill-in for the superclass's name. So you're calling the superclass's constructor if you just say super. However, if you say super.method, you're calling a superclass's method. So if it's super.display, it would call the display function from the superclass. If it's super.move, you would call the move method from the superclass. So I'm going to go ahead and write these down as well. Let's see here. Super, okay. Here's what I'm going to do just so I can see both of them really quick. So sorry, so sloppy. There we go, there we go, there we go. And you need to be zoomed out so I can see you. Thank you. Perfect. Almost perfect. He's done it. Okay. They said it couldn't be done, and then he went and did it. All right. So the uses of super. I know you guys already have these mostly written down. Thank you for taking your copious notes. I just need to write them down as well. One, if you just say super or super, when you see the word argument, it's just like the values that go in for the parameters. You can just say parameters too for most of these cases here. This will call just the superclass's constructor. And obviously it has to be the first line of your subclass's constructor. You guys don't need to hear me say that again. And then the other use for it is if you say super.method, where that method is obviously just a placeholder. You can super.display, super.draw, super.move, super.whatever. This calls a superclass's method. Okay. There we go. If you don't have it written down, you can read along from here and write down. So the keyword super is very useful in allowing us to first execute the superclass method and then add on to it. When would you want to do that? Well, for example, last night if you were overriding display, instead of you going ahead and changing the fill color, you going ahead and drawing the ellipse, that's what the display method already does involve. So you don't need to write that yourself. You can just say super.display and it will do it from the display method. If you overrode move, you could call super.move so that it still changes the x values using the x velocity and the y value using the y velocity, and then you could augment it or something like that as well. Two-string methods, for example. Your two-string method, you might want to print out a person's name, but then you want to add on to that with a person's employee's ID number or something like that. Then you can do super.method. So it's super duper useful for us, super, because the keyword allows us to first execute the superclass method and then add on to it. So anything that you override, you can use the parent class's implementation and then add on to it how you've overridden it. So I'm going to have you guys do this example. It says, in the example below, the student class overrides the getFood method of the person class, and it uses super.getFood to call the person getFood method before adding on to it. Here, a person is associated with the food hamburger, and a student is associated with hamburger and taco, hungry student. Add another subclass called vegan that inherits from the student class. Override the getFood method to call the superclass getFood, but add a no in front of it, and then add a vegan food. Interesting. So let's look at this for a second. Don't ask me why they have this equals null. It's totally unnecessary. Person looks like the superclass because it doesn't extend anything. Person has a constructor that sets their name. Person has a getFood method that returns hamburger. And so student is a person. We can tell because student extends person, but it also has an ID number. The first thing we do in its constructor is call the superclass's constructor, and then we set the ID number. Now, its getFood, this is where it gets interesting on line 36. When I say super.getFood, which class is it going to go to find the getFood method? All right, guys, go take a 2-minute break. Half of you are like asleep. Go take a 2-minute break. Go take a 2-minute break. It was 3. You're right. right. So let's review where we were at. Let's see the hierarchy. Student is a person. On line 36, when I say super.getFood, first of all, it's very important I say super.getFood instead of just getFood. If I just say getFood, you know where it's going to call the getFood method from? Right here in student. When I say super.getFood, though, it's going to call the getFood method from person. There we go. Okay, nice work. So what does person's food method return? Hamburger. So now output is going to contain hamburger. Where did it get it from? Well, it got it from super's getFood method. Then it's going to return whatever that is plus taco and taco. So this will be hamburger and taco. If I go ahead and run it, is that what it says? Hamburger and taco. It sounds delicious. What if I didn't do super here? So I just want to explain why that's a huge issue. If I don't say super, where is it calling the getFood method from? Student, right here where we're already at. Think about the issue I've just created. When I go ahead and say getFood, line 36 is going to say, okay, go ahead and call getFood. Then I go back and I call getFood, and line 36 is going to say, okay, call getFood. And then I go back and I say, call getFood, and line 36 is going to call getFood.
It's like your OBS.
Yeah, it's like this.
Yeah.
You can see forever. If I run it now, I bet I get like an error. It's still running my code. It's still running my code. It's still running my code. Still running. Stack over. This is how many times it called getFood from student before it ran out of memory. Okay, so what's the moral of the story? Don't do that. All right. So again, why is it important that I say super.getFood? Because, okay, listen. So if I don't say super.getFood, it's going to use the getFood method most local to right here. Since I overrode getFood on line 34, it's going to call this getFood method unless I use super. Super says go use the getFood method from the super class. So I do that, I get hamburger, and then I tack on and taco, which is more than enough food. I know, hamburger and taco. You guys are supposed to do this part. Add another subclass called vegan that inherits from the student class. Override the getFood method to call the superclass getFood, but add a no. All you have to do is write the class. You don't have to write a constructor even. Just write the class vegan that extends student and has a getFood method that overrides. I'm going to walk around and help here for the next couple minutes. That's what you're doing though. Let me just pause. Alrighty, let's see here. Let's see. Okay, class person. I'm going to write it right after student because it is a student, so I'm just going to put it bonk down here. So I'll say something like class student, class vegan extends student. So really quick, is a vegan a student? Yes. Is a vegan a vegan? Yes. Is a vegan a person? Yes, a vegan is also a person. I'm going to start with the getFood method because that's the big one. It said override getFood, so if I'm going to override, I have to have the exact same header. So I'll do that. And then it says it's supposed to say no, followed by the hamburger taco. Many of you did it on 2 lines, so I'll go ahead and do that. I'll call super.getFood, so I call the superclass's getFood method, which will be hamburger and taco. And what I'm supposed to do is return no. Like, why doesn't this person just order what they want instead of saying not one thing first? It's strange. And then I'll do I want. What did you guys say the vegan's having? You guys are so judgy of vegans. If that was another group of people and you were saying that, do you guys see how culturally sound I am? Are you guys picking up on that? So I'm just gonna say salad. Come on now. Okay, he's just going to say salad. Or she, or they. Then after I go ahead and make the get food method, by the way, if I don't want to make output, I could literally just take this and toss it in right here. If you don't see why we're doing this stuff, I kind of understand you. But it's basically so I don't have to type hamburger and taco myself. The superclasses get food method already does that. So I'm calling the superclasses get food method and saying no hamburger and taco, salad. Maybe I should say salad, please. Usually vegans are very polite, as are other people, and I like all cultures and say what? That I like all culture? Oh, that vegans are polite? I hope none of them are offended. If you're listening, I'm so sorry. Now I think when I run it, it says it doesn't like it because I don't have a constructor. Gosh dang it! The reason is the student's constructor. There's only one constructor for student, and it expects a string for the name. There's no default constructor, so I kinda lied and said you don't need a constructor when you definitely do. I'll take in a string, the name, and I'll just go ahead and pass it to the superclasses constructor. I think that's the whole student class. Oh, and then I'm supposed to change Javier to a vegan. Sorry, this is the whole vegan class, I believe. Javier, come here and be vegan. Sorry, I'm like all over the place. There we go. There's the whole vegan class. Javier says, no hamburger and taco salad, please. Very polite, Javier. How should I say that then? As some vegans are and some are not, and that's okay either way. How am I doing? Good. Good. I get 30 emails a day, so okay. Oh, sorry. Javier was thank you, Ben. Javier was already made in this main method up here. I just changed his I changed it so he was a vegan. Yeah. Yes, Ammon. No, it could be, that's a great question, Ammon. This could say vegan as well. We are going to talk about the way that these variables are declared and instantiated very soon. But basically, you can always put the superclass on the left and the subclass on the right. It just makes, we'll talk about more in depth later on. But you can do this. What I could not do is switch it. I couldn't say vegan V equals new person. I can only say person P equals new vegan. The superclass has to go on the left, subclass on the right. I could also say student S equals new vegan, because that would be superclass on the left, subclass on the right. Good question. No, yeah, it's not super duper necessary. Okay. All right. Is that it? No, we got one more thing to do. It says, how does this work? Remember that an object always keeps a reference to the class that created it and always looks for a method during execution starting in the class that created it. So as an example, let me draw out our hierarchy really quick. Up at the top we had person, then after that we had student, and after that we had vegan. Since Javier was a vegan, he looks for the get food method inside of vegan first. Then from his get food method said super.getFood. Well, super.getFood is in the student class. And so when I do super.getFood, it's going to call the getFood method from student. Now, if you remember a few steps ago, student's getFood method returned hamburger, I think. So then when I say super.getFood from inside of student, it goes and it gets hamburger from person. So basically what's happening here is vegans getFood method called, it basically said no, and then it called super.getFood, and so then inside of student says call super.getFood again, and so up here in person, it's going to say no, I believe it's hamburger. And then after it returns that from person, it comes back down to student. Student added on and taco. And then back down to vegan, I added on salad, please, or something. So that's kind of the whole stack trace of what's going on. Vegans get food method called students get food method by saying super.getFood. Students get food method called persons get food method by saying super.getFood. Persons get food method return hamburger. Students tacked on and taco. And then the vegan one tacked on salad please afterwards. You guys following that? Okay. All right. So remember, if it doesn't find it in the class that created it, it will look at the parent of that class. It will keep looking up the ancestor chain like I just drew out until it finds the method, all the way up to the object class. The method has to be there or else the code would not have compiled. When the student getFood method is executed, it will start executing the getFood method in student. When it gets to super.getFood, it will execute the getFood method in person. This method will return the string hamburger, then execution will return to the getFood method of student and return the string hamburger and taco. So it's going like up and down the whole hierarchy chain there. All right. Here's a question. It says, given the following class declarations and assuming that the following declaration appears in a client program, the word client program just means like a class that has a main method or tester class. Base B equals new derived. What is the result of the call b.method1? Okay, interesting. So it says it's made with derived. So it was made like equals new derived, and it's doing b.method1. Okay. Let's see here. Method 1 says first call the superclasses method 1. Sugar, what does, I'm zoomed in too much. The superclasses, okay, so method 1 here calls the superclasses method 1 up here, which will print out an A. Oh, gee willikers, I see it. Then this calls method 2. Which method 2? Okay, so this is like so confusing because you're in the superclass right now and it says method 2, so your logic would tell you, oh, I'll just use method 2 in the class that I'm in right now. Not so fast. This is a derived object, so when I say method 2, I have to first see if derived has a method 2. Derived does have a method 2. It's down here. This calls this. So this object B is made in the derived class, so any of these method definitions it's going to look for in the derived class. So it's when we let me start again. When we said method 1, we look for the method 1 inside of the derived class. That then called super.method1, which is up here. This prints out an A. Then when I say call method 2, well, since this object is of the derived class, I call method 2 from the derived class. So this calls method 2 from down here. However, the subclasses method 2 says go call the superclasses method 2. Okay, the superclasses method 2 prints out B. Then when I'm done with that, I come back down to this method 2 and I print out D. Did I miss anything? Oh, I forgot to print out C. C gets printed at the very, very end, it looks like. Back all the way from this here. I'm going to go with ABDC. Is it ABDC? Let's read this explanation. Maybe it'll say it better than I did. It says, even though B is declared as type base, it is created as an object of the derived class. So all methods to it will be resolved starting with the derived class. You know, I'm actually going to add that to my notes. I think that's super duper important. Because some people are like, what the H is going on? Let's go ahead and add that to our notes. So I'm going to call this calling methods. So essentially if, let me zoom in a little bit, sorry. That better? If an object is created as follows. And I'll say something like parent obj equals new child. Something like that. Any methods called on obj will first be found in child. So even though it's declared parent obj equals new child, or super obj equals new sub, or base obj equals new derived, however you want to put it, you're going to look for the methods in the class on the right. Maybe that's an easier way to put it for some of us. In other words, I don't know if that's a real abbreviation. In other words, methods will be called from the class on the right. Or whatever constructor is called. So in this example, the child constructor is called, so you're going to look for the method definition in child first. Now, if you don't find that method in child, where are you going to look next? The superclass, parent. And if it's not in parent, you look at parent superclass. And you'll go all the way up until you get to object. And if that method's not inside object, guess what? That method doesn't exist anywhere. So you always start looking for the method in the class on the right, and then you go up the hierarchy until you find the method. So I think I need to do this question one more time because there were a lot of glassy eyes there, blank stares. So this is created using derived constructor. So it is of derived type. So when we say method 1, this method 1 from derived is called first. This is the first thing that happens. I go ahead and I call super.method 1. Super.method 1 is up here. A is printed out. Then from that it says call method 2. Okay, I'll go call method 2. Since it's a derived type, it'll call method 2 from the derived class. Even though it's in the superclass when it calls method 2, since this object is of derived type, it'll call method 2 from the derived class. Then this one calls super.method 2, so then control goes back up here. It prints out B. Then when that method's done, it reverts control back down here. It prints out D. Then method 2 is done, and it reverts control all the way back to when we originally called super.method 1, which was right here. That's now done, and then we can finally print out C. I don't care if you hate this question or love this question, but there is always one question on the AP test that's just like this one. Daniel.
So how would you call
How would I call method 2 from...
method 2 as the responsible in the subclass?
You ready? Anybody want an answer before I type it?
Since
You answered your own question, you stinker. What am I even here for? All right. Yes, if I want to call method 2 from inside of method 1 in this class, I want to very specifically say this method 2, I literally write this. I know some of you are like, oh, you know, why do this? This is why we do this, in case you actually want to specifically say call this method 2 instead of the derived class method 2. Now, furthermore, Daniel, I guess we could do something like, what is this, base? If we made the object like this, and then I call, like, let's think about this. If this is how the thing is created, if I say b.method1, then it will call this, print out A, and then which method 2 is it going to call? The one right here, because I'm in the base class. This is made with basis constructor, so it would know even if this is not here, when I say method 2, since it was created with basis constructor, it'll look for the method 2 in the base class. So it changes very, very much depending on which constructor I use. I think that's a really good question. I bet it spawns other questions. Annie, yes? So if I do base, so the difference is their question, I think the original question was like, I don't have it on the screen, but I think it was base B or something like that equals new derived. That was the original question. But if I were to actually change it so it's base B equals new base, whenever I call a method like b.method1, it's always going to look for what constructor B was created with. Since B, in this case, is created with basis constructor, it'll call method 1 from base. It'll print out A. And then when I say method 2, it'll call method 2 also from base, because that's the constructor that was used to create it. I actually can't call anything from the child class. I can't say like child dot or sub dot. Inheritance doesn't go in both directions, so I can't call anything from derived if it's of type base. So like if I make it like this, base B equals new base, I can't use anything in derived. Because the inheritance is only going, derived extends base does not extend derived. Does that make sense? Yeah, okay. It's just like your parents don't inherit from you, you inherit, unfortunately for some of us. You inherit, I hope you're not listening, Mom and Dad. You only inherit from, okay. No, not only do my mom and dad not listen, nobody listens to it. So. It's not sad. It's just like I might as well yell into a tin can. All right. Okay. There's a little activity at the bottom, but I think maybe we'll skip it. Oh, I was going to show you how you could do it in processing really quick. Check this out. Just one last thing before I get you done with this stuff. I did pull up cool processing stuff, ball classes. Okay. So you guys were doing all the stuff with the ball classes last night, and you did a fantastic job. Did I say you guys did a fantastic job? You did a fantastic job, if I didn't mention that. And there were some parts like display and move and bounce that you overrode. So here's what you could do. Check this out. For my big ball class, I rewrote it. To make a big ball, I just said make the diameter 1 bigger, and then I said super.display. So what does that mean? If I say super.display from big ball, where's it going to call the display method from? The parent class. What's the parent class? Ball. So then after it goes ahead and sets the diameter, then it will just, where is it? Then it will just do all of this stuff in display. So instead of like I know you guys are probably want to come hit me or something like that, because you guys had to, when you were overriding, you had to redo all of the stuff. You can just say super.display, and then it does all the stuff that's already in display. Flashing ball. For flashing ball, I had to change the color, but then it displays just like any other ball, so I set the color to something random, and then I called super.display. And so they'll just call the superclass's display method instead of me having to go through and rewriting all the code that displays it. The superclass already displays it very well. Then I don't have to worry about writing accessors and mutators and blah-de-blah-de-blah. Yeah, Ian? Yes, back in the base thing. I can switch windows. Go ahead.
Adding this to it, it still calls the derived function.
I'll have to look at it. Anything else? John?
What's the poop ball class look like?
The poop ball class? Oh, you wanted to see the poop ball class? So if you don't remember, poop ball is you can figure out pretty quickly what poop ball looks like. Wait for it. It's like cellular division, kind of. So here's what the poop, to make the, if you guys wanted to know, which give me 1 second. I need to pass something out. Then I can, you want to see the poop ball class? I can do that. Yeah, I can do that. Just give me 1 second to explain it first, and then I can go ahead and. So the poop ball class, what I did was, I said basically every time that the poop ball divides, it makes a new poop ball, and I put it into an array list. So up at the top, you see I imported array list, and then I went ahead and I said, go ahead and make it so that there's an array list that contains poop balls, because I wanted it when it pooped out a ball to poop out a poop ball. And so basically I said, go ahead, call the superclass constructor for ball, set the I started the diameter at 500, and then I said, go ahead and instantiate the array list. Now, for the moving, I said it moves like usual, except basically this is how I made it set up so that it was about every second. I'm going to change the diameter of the poop ball, create a new poop ball, set that poop ball's diameter to the same diameter as the one I just have, and then make it the same color. So when you see it run, when a poop ball goes in half, they both have the same size and the same color and the same size and the same color and the same size and the same color. And so after I go ahead and make it so that that new ball is the same size and same color as the old ball, I add it to my array list. And then the display method, look at that, super.display. It displays just like any other ball, except then you have to go through all of the balls that were pooped and display those as well. Yes?
So could you make it so that the poop ball is getting bigger, and then it, like, once it gets to a certain size, then like poops, and then it gets bigger and poops again?
Yeah. Absolutely. I don't know that I have time right now, but I think that some people requested that I put the poop ball on the paste bin, so maybe I'll do that, and you guys could do that on your own. What just came around? What goes around comes around. What just came around is this. Sorry, it's sideways. This sheet, it's got a small amount of questions, 10 in total, but there's some super class stuff. Now, I know on the front it says exit ticket. Both sides are your assignment. It's a very short assignment. It's 10 questions. And it's all about using super on overridden methods and stuff like that. So, I don't know. You probably could finish it before you leave today. Yeah, today we learned about super. And super essentially allows you to call an overridden method in a subclass. It's like this, but for the superclass. All right, that's it. You know your assignments, that worksheet, easy money. Nice job on the ball stuff, and